Welcome to the migration of regular WAN to SD-WAN session here at the Partner VT. My name is Bill Wazalewski. I'm a Enterprise Network TSA in the channel. And we have Prashant here to walk us through a pretty good presentation on migration, things to consider, and the overall solution.
All right. So, thank you, Bill. Good morning, everyone, and welcome to Partner VT session. And my name is Prashant Tripathi, and I'm Technical Marketing Engineer for SD-WAN. I mainly work for APJC and EMEA, and this is the first time I'm doing here, so thanks for joining. So today, we are going to talk about the migration from SD-WAN to, from traditional to SD-WAN, and what do we do to migrate from, traditional to SD, what sort of things we have to take care about, all those aspects we're going to discuss here. So there are a couple of things we're going to cover in this. We're going to talk about the planning. We're going to talk about how we're going to migrate DC sites, how we're going to migrate hub sites, as well as a branch migration, what we should do when we migrate from branches from traditional to SD-WAN. And then we summarize things. All right? So how many of you are familiar with these components? Yep. Nice. So I'm sure everybody in this room should be knowing about Cisco SD-WAN and the components what we are using as of today, considering control plane, data plane, and the pointers, what we do. So I'm not going to go into deep dive to each and every component, but I'm going to talk about as a high level what they do. And please feel free to ask the questions if you have any, so that we can make it very interactive session. Thank you. So as we all know, in Cisco SD-WAN, we have decoupled the control and data plane. So if we look at absolute bottom, we have a data plane, which can be a virtual, which can be physical, which can be a VH, which can be ISR, ASR. Anything which is running SD-WAN is what we have a data plane. On top of this, we are going to get a quality of security, which we are launching in November, as well as a multi-cloud stuff and app queue sort of result, because whenever you have a data plane, you're going to run a lot of applications, and you need to have visibility for those applications. And if you, as I asked, you are very familiar with the slide, so and the components. So if you see in this, we are missing the vBond. So vBond is orchestrator, so we just did not keep it here, but yeah. So as you have already gone through the component-wise, so you must be understanding what vBond does, what sort of orchestration, what sort of role it plays in the SD-WAN components. So if you look at the controllers is the guy who takes care of the routing updates and OMP stuff, and he's the decider for who does what and sort of policies we're going to do on the controllers. And then there's the NMS, which is vManage, and from which we can monitor the stuff, defining configuration policies and all the things, just like NMS, what it does. And then the last part is analytics. Analytics is additional sauce which grabs the information from the vManage NMS and does a predictive analytics for you. So any questions do we have so far on this? All right. So if you look at this part, so all of us have been gone through these use cases, and we have multiple questions from partners and the customers. How do we do for SLA-based routing? How do we do for service chaining? So all these aspects, we do that, some of them through the policies, some of them is the local policies. And there are many ways to achieve that. Could be simple, could be quite complex, but yes, as based on the scenario, we can go through that. So I'm not going to read those parts, but just for your information that this is what we do in this. If you have a use case, yes, we support those parts. So whenever we migrate from traditional to SD-WAN, so the only thing we have to spend time is the planning, right? doing configuration, doing policy push is a simple thing. It's like zero touch technically, right? The planning is where we have to spend time to understand what sort of template I'm going to do and what sort of configuration a site needs, what sort of policies it requires to work on SD-WAN, considering the network requirement, right? So the planning where we're going to put the effort, and if you consider that we are replacing MPLS totally, so it's partially true, but not completely, right? So we're going to keep it there based on the need. On top of that, we give SD-WAN services, right? So the planning where we have to focus more than other stuff. Other stuff is quite plug and play now. So whenever we plan for migration, so the only thing that comes first is like whether we should go for the cloud controllers or on-prem controllers. So the first step, you have to plan the cloud controllers or on-prem controllers, and that's the first plan we have to build out before we roll out our data plane stuff, right? So if you look at cloud controllers, Cisco offers as a service where Cisco is going to take care about all the firewall, all security rules, and everything as a setup, and offer you as a service, right? So the first step, we are going to have built out the controllers, and then we go for whether we build out a data center hub and how to migrate that part. So we start with the control plane, and then we go to data plane. Data plane, we go for data center as the first site and do the migration for that, and then we move on to branches, right? Branches are spoke site. So that is how we plan. It's like planning a control plane and then data plane, and then go for hub and spoke models or the branches scenario. So as I discussed, so whenever we plan migration, the first thing we have to decide is like control plane, whether it's going to be on-prem or on cloud. Whenever it's going to be on-prem, the first thing we have to do is we have to have the firewall rules, we have to have security parameters taken care, so we have to have form those and fix those parts first. So it's like planning the controller deployment model, either cloud or on-prem. If it is on-prem, then we have to have all the security components and rules open to have communication from a data plane to control plane. And the next is like having your, planning your controller redundancy, like having a high available controllers, and then we have to plan the scale. So if you look at like every controllers have a limitation to support number of devices, right? So if you go from the left again, it's like planning your controllers, which mode you want to follow, on-prem or cloud, and then next goes is like what sort of firewall rules you have to open or you have to block, and then third is like redundancy for the controllers along with the scale, whether a controller can support 2,000 devices or not. Considering number of devices, you're going to plan those parts, right? So these are very important aspects of planning when you migrate from traditional to SD-WAN. And if those controllers are hosted in Cisco SD-WAN cloud, the Cisco is going to take care about those scales and those redundancy and which region they're going to keep your controllers as a active standby. So those things are already taken care of. So that's the advantage on that. So as I discussed, so we have two controller models. So one is like cloud, one is like on-prem. So if you have cloud controllers, which is taken care by Cisco, which means Cisco is going to take care about your firewall rules, about anything. It's technically additional services to you. It is not like you have to consider about going to the IT and getting those firewall rules fixed and then come and implement that, right? All the scalability, all the specs, and the things are taken care by Cisco if it is cloud-based, right? The on-prem is where you have to plan about considering and using your specs and know all the rules and as a components to open. So the recommended model, what we say is cloud-based controllers. That is where we promote as well, having controllers on cloud-based, and until it is very financial customer, let's say banking, who has some restrictions, not go for cloud, or some country has restrictions, not go for cloud. So we recommend you to go ahead with Cisco cloud controllers. Any questions? Yeah.
Are those controllers still only hosted in AWS? Or are you guys planning to move to a multi-cloud?
Yeah. So we have Azure as well. So we support AWS and Azure both. Yeah. And in terms of on-prem, you can go with KVM, you can go with OpenStack, you go with ESXi. Yeah. Thank you. So if you look at about the communication of the controllers and the data plane devices, right, how it happens if it is in Cisco cloud, because the devices comes from a customer premises or could be virtual and physical, there has to have a communication. So how they build out the communication, right? So your device will always point out to the orchestrator device, which is a vBond we call in today. And the vBond will always connect to you as a VH to the controllers on a public IP address, which is a netted IP address we do. So all these aspects are hidden for a customer perspective that Cisco takes care. These are only needed if you are troubleshooting something and you would like to understand what are the ports open, what are the IPs are done, but these are technically taken care. If it is a Cisco cloud hosted controller, it's like a service which is already taken care, and you don't need to worry about whether my public IP communication should happen, my netting should be done, that there are what sort of port I should open, right? So these are the pointers. And if you have a transport like MPLS, right, it's an optional you can enable control connection, or else if you really need that, let's say if you want to have redundancy for the MPLS as well, you can NAT that and have communicate via vBond and then go through the vSmart and vManage. So ultimately, if you go with the cloud hosted controllers, so these things are already covered. Those netting parts, the communication, you don't need to worry about what's happening in the background. The Cisco is taking care of all these parts as of today. So do we have any questions? I believe most of the customer, when they have MPLS and internet as well, they consider, okay, how I'm not able to build my control connection from the MPLS to the controller. Is it needed or not? If yes, how can I build? If not, then what should I do to avoid that part so that I can have my data connection up on that particular transport? So this is very commonly asked question, and just to let you guys know, yes, we have multiple options to do that, either netted way or from data center netted way, or you can disable control plane on the MPLS transport. So for any questions about controller communication? All right. So as I think most of you are aware about our control plane, so you must be aware about the certificate what we use as of today. So initially we used to use Symantec. Now Symantec is acquired by DigiCert, and we use the DigiCert certificate as a default in our cloud-based controllers, right? But you as an enterprise, if you're hosting controllers on-prem, you have rights to use your any CA which you would like to. So that facility is available, and you can just leverage having that sort of certificate. It's not like we are forcing to have the one certificate. It's up to you that if you trust something, and you can go ahead and use that if it is on-prem controllers. All right. So there are So there are two ways you can deploy your on-prem controllers. One is having all the controllers on public IP address, right? Advertise that public IP address to your MPLS cloud and let MPLS transport communicate via that, right? Ultimately, what you point at your VH device is public IP address of your controller, which is a vBond. And the vBond lets every controller know, or every controller's IP know to you in order to have a communication. And if you would like to have, let's say there are a couple of companies, especially I have been couple of customers, their security team do not allow having public IP address on the controllers. So they would like to do NAT. So in that case, if you're doing NAT, you can go ahead with one-to-one NAT and then advertise that NATed IP to the MPLS cloud and let VH device talk to the vBond NATed IP address. As long as they're going to talk about NATed, they are going to talk to NATed IP address. That communication between the VH is going to go through on public IP address through the private transport. All right. And there are a couple of ways if you want to do communication on the private IP address. You have just one provider, and you have public private IP address, and you're NATing as well. So there are multiple ways you can make it happen. And it is doable, but the recommended way, what we say is like either have public IP address and advertise that public IP address to the MPLS cloud, or else NAT it and make sure the controllers, which means vSmart, vBond, and vManage, should talk to each other on a public IP address where it is public or when it is NATed, right? and have that public IP address or netted IP address to advertise in the MPLS cloud in order to connect the device via MPLS transport to build out the control plane. Do we have any questions? Because generally you see these pointers when you have a financial customers where they're going to have those transports and they don't want to expose things out. So that is where we use these parts, and these are the solutions we have available at the moment. All right, so I think it's already covered this. So as I discussed, the firewall rule is very important here. So I'm not going to read these firewall rules. What we have is just a high level, or if you, to discuss here that we have summarized the rules, what you have to open from the VH to the controllers in your firewall when you're doing enterprise controller hosting, and that is how we should do. There are support pages, there are PPTs, or there are documentation we have listed where it is quite granular, and you can see and figure out what are the ports and why we need that. And if you look at, there are multiple range of the ports. There are many reasons about it, because the controllers like vSmart and vManage have multiple core. They build out the control connection on each core. That's one reason. And second is, like, let's say your firewall has something that is timing out, so you can port hop as well. So there are a couple of reasons to have these many ports in order to open from your firewall towards the controllers. As well as if you have any specific questions where you have some issues, we can take it offline after the session and discuss about what we should do or what we should not. So in order to have redundant controllers in your solution, you as a customer, we have two offerings. One is when you host the controllers in Cisco Cloud, what we do is we keep a set of controllers in a region and another set of controllers in another region. But if you look at here, we have a vBond in a region, and we have another vBond in another region, and vSmart. But if you look at the vManage, it is active standby. That's how it is designed as of today. As of today, it is cold standby. If one of the vManage goes down, you can have another running, just export the config DB of it, right? But if you have more, let's say you have around 2,000 plus VHs, right, which is, you need a scale, we have a cluster solution as well. So you can have a node of 3 as a cluster in vManage, and you can keep into one of the region and use the cluster. And it can help you on high availability as well, plus scale parts. But when you are hosting controllers in your private cloud, which is on-prem, what you're going to do is you're going to have one set of controllers in one data center, another set of controllers in another data center. And from there onwards, you're going to take care about how many controllers do you need based on number of devices, based on the customer need, and you plan accordingly, right? The advantage, if you look at here, if your controllers are in AWS, what you do is like you keep running a snapshot. If something goes down, you can just restore the snapshot. Having things here in on-prem solution, you're going to have export database and do that. It's quite extra work for you sometimes. Apart from that, this is fine. So do we have any question on this? That's also quite known. I mean, it's sort of quite known topic.
So how are backups handled when it's hosted in Cisco data centers? Does Cisco automatically back it up? Will they do restores? And can customers back it up and keep it on-prem if they want, their own backup copy?
All right, yeah. So for vSmart and vBond, they're going to be active. Only the vManage is where we have to take those backups. So we keep taking snapshot every day. We run 10 snapshots, and we keep it as a backup. So if in case your vManage goes down, we can take those snapshots and restore to your regional vManage, which is another region as a standby, and bring the services up. As well as it's always NMS. So whenever vManage has an issue or it goes down, it is not impacting your services. It is just NMS. But yes, the smart way, we have a snapshot. We just go ahead and put the snapshot, and it's up and running. So it's no interruption services.
Where are those snapshots? Are those snapshots stored in the same public cloud in the same region, or are they in a different region?
We have option to choose that. We generally do that. Let's say my vManage in region 1, I have option to choose that snapshot to be another region, and then I can grab that. Because if I'm going to keep in the same region, if something goes down, everything's out.
Yep. So the customer can't actually export the config themselves and keep their own on-prem backups?
So you're talking about the on-prem case?
No. So they have a cloud hosted. They just want to export the config, keep their own backups.
Yeah, they can. So you have options. You can grab it as well with the command line, or you wanna export config DB, you can do that. Then you can take to and restore somewhere. There is an option. But snapshot is quite smart way. It's everything is taken care of by a Cisco cloud upstream. And as a customer, you don't need to think about what should I take and what I should not. So that's one part. We have mentioned a couple of times the scale numbers about the controllers, how many devices each controller handles. So these are the one. I think this is quite a slide where you guys have seen multiple times while working for a customer. So if you look at the limitation perspective, each vBond supports 1500, and that's what we have tested. There's no hard limit, but that's what we have come up, and with our testing, things are quite well. And each vSmart goes up to 5400 connections, and the vManage goes up to 2000 as each. As I mentioned, the vManage cluster is always when there's a scale issue, or if you want to scale your v edges, and that is where you go for cluster. Otherwise, active standby is well enough. So these are the numbers. If you guys have any questions on the numbers, we can talk on that as well offline. So there are scenarios we have seen with the customers. Let's say they have 3 regions. One is in APJC, one is in EMEA, another is in the US, right? Every customer would like to connect their nearest vSmart controller, right? So we have terms, we call it affinity, where we can say for each of your region, you can have your vBond FQDN, and you can point your devices to that FQDN, and you can prefer a controllers of your region. So what generally we do, we set all the controllers with a specific group, and we can tell you the VH devices, which group you should gonna connect, right? Similarly, if you look at here, US is in group 1, and EMEA is in group 2, and APJC, APAC is in group 3. What happens in this, like your edge device reach out to the vBond, right, and connect to the vBond as a regional, because you can have regional FQDN for your vBond. Let's say you have 3 vBond, you can have their IPs and define a new DNS and put your VH as a DNS for your vBond in a region. This generally comes with latency need, or there are some specific need in your case where you don't want to have a sort of latency in order to have control connections. And there are a couple of pointers comes into the picture where you have generally say regulations where you don't want to connect to outside your region any controllers or outside the country of any other controllers. So that's the one way, right? So reach out to your vBond with the help of FQDN, and then have a controller group ID defined where you can prefer which controller you want to connect first, and if that goes down, you have order of operation to connect second and third, right? So in this case, let's say if you are in APAC and you want to connect APAC as the first, but you want to have EMEA as the second, and then America as the third. You can define the sequences. Let's say first is this one. If that controller goes down, I want to go for another one. If that also goes down, the third is my America one, and that's how I can connect, and I can have high availability maintained along with my latency requirement, what I have today. But keep in mind, vManage is NMS. I can't have vManage every region. So I can have one of the location that we can decide whether it should go for AMER, EMEA, or APAC, and keep it one of the data center. All right. So any question do we have? Because generally we have those requirements from the customer where they want to connect to their regional data center or regional controllers in order to build the control plane, data plane, and they want to fall back to another region if that is out of reach, and that's how it is. So whenever we plan for migration, so how we consider things, right? The first thing, like your device goes and talk to PNP or zero-touch server, then we push out the control connections, and then our policies get pushed out, and based on the control policies, the data policy, we build out our connections with the device or another device and prefer link. So these are the 3 parts which are very important. Having a device connect to zero-touch server, a plug and play where you don't want to put any effort, it is plug and play. And the next step is always getting the template and policies, and then scalability is the last part where we have to think about whether I should go for hub and spoke, considering my number of branches, the device which supports number of tunnels. Based on the scale, we go ahead and plan about it. So these are very important aspects of migration where we have to consider whenever we are designing a regional solution or the branches which are, I would say, on other routers if they are not capable of supporting those number of tunnels, considering number of branches. So I think how many of you are familiar with ZTP or PNP in this room? Nice. We have good numbers. Thank you. So how about the PNP? Have we tried PNP? And the differences of PNP and ZTP, anybody is aware about? Technically, they function the same way, but what is the differences? So if you look at the VH boxes, they talk to ZTP server. If you look at CH boxes, which are ISR and ASR, they talk to plug-and-play server. VH boxes always go to ztp.viptela.com. They resolve ZTP of Viptela, and they get mapped to your overlay, and they talk and get the configuration posted. And Cisco boxes like ISR or ASR, they go and talk to device helper, and device helper has a controller profile set up, and they talk to the controllers or your overlay after which, right? So the best way, as you are aware about, whenever you buy something, any devices, any of the, I would say, solution in terms of SD-WAN or any other, so we have the smart accounting concept. So we're going to keep your device noted, like what this device belongs to customer X, and we're going to give you a smart account. In this smart account, you as a customer are going to manage which device and what sort of controller profile do you need, right? You can have multiple controller profile, you can have multiple network in order to have PNP, right? You can have, let's say, your company like Gap. Gap has Gap has a retail store and CarpNet as well. They can have one smart account, they can have two virtual accounts and two controller profile altogether different, and their devices can talk to their separate overlay in order to have plug and play or ZTP, right? So it's just like having your device information in the plug and play or ZTP server, and in the ZTP in the virtual account concept, you're going to define your controller profile where you say, okay, these are the devices. If they comes to me, please point out this configuration when I say have this org name or have this vBond. So you're going to do the redirection from the controller profile. The moment you plug in a device with the help of DSCP pointer, it will go and resolve devicehelper.cisco.com, and it reaches out to your PNP server and look at the profile. Based on the profile, it gets the org name or your vBond information and reach out to the vBond, and the vBond connects to the vManage and the vSmart, and the vManage will have a template, push out the template, and bring up the device. And device gets the configuration from the vManage. And then it is done. Yep.
Is that initial communication between the WAN edge device and the PNP server, is that HTTPS, or what's that initial communication look like to the PNP server?
Okay, it's a DNS-based query. Okay. Yeah.
So just do DNS query.
DNS query, and then it's reach out to the PNP as of today.
Okay.
Yeah. Yeah, so but the one thing is like currently we support just the DSCP, and we don't have auto IP capability like what we had in VH, but we are working on similar capability to come up something. Yeah. So in terms of configuration template, I'm sure you must have gone through the configuration template, what it does, what sort of setting we need to have. Like, it's not necessary to have one template to attach 100 devices or 100 template attaching to 100 devices, right? So you have to plan those things very sensitive way and define it what can be a common pointer. Let's say system. System is something you can have a common template for every device. The system going to have host name. You're going to have the GPS setting and a couple of things, right? So there are a couple of parameters that you can set it. As of today, if you set up the default setting, default means it's not going to change anything. It's going to be as it is, what is your device. And second is like you have device specific. That is where you can set up a couple of parameters like system and all. You can set device specific, and for those devices, you can go and set a value for it, right? So ultimately, in that case, you are able to use just one template for 100 devices, but not everything, but it's just a couple of parameters of it, right? Because when you use at everywhere, then you're going to have difficulties, let's say, if you have some different sort of requirement to do that, right? So there are a couple of values, like you can have a default setting, which means no changes are going to happen for that particular parameter, considering these. If you want to have device specific, which means when you attach the template to the devices, you're going to have to fill those parameters, which can be to the device specific, which can go to every device is going to have unique parameters, right? When you say global, global means you're going to put the value, and that value is going to be to be common to everybody, and that is what we have as of today. Do we have any question in this? Because template is like we have a lot of things when we attach to the devices. As I said, you can have one template to 100 devices, and sometimes you can have 100 template to 100 devices, but you have to plan your templates a very sensitive way so that you should leverage a template to cover most of the devices. Let's say you can divide based on the data center category, you can have branch category, you can have regional category, and define the templates accordingly. This is how it looks like. So when you go to the template, you can see here this feature template has been called 16 times. How many devices it is attached? What is the device model? It's not necessary to have this template just for one device. You can change the device model. You can have this template for some other device. Let's say you can have ISR here. You can have ASR. You can have your VS1000. You can just put those device models, and this template can be applied to those. It's not necessary to have a template for one device model, and then you can create another template for another device model. So you have an option to use the same template for multiple device models. Could be ISR, ASR, VS1000, VS2000, anything you would like to. So ultimately, you have option to leverage those options. Oh, sorry. This is very important tool. We have recently introduced this. If you are having XC router, let's say ISR 4K ASR 1000, right? How you convert your configuration from legacy to SD-WAN. Today, what you do when I say today, means before this tool, what you do is like you have running configuration, then you plan what is going in transport side and how should I convert that transport side configuration to Viptela to SD-WAN world, right? To do that, you have to do manual stuff. You go one by one and then figure out what is supported, what is not supported, which command. And sometimes it's very difficult to figure out this command, what could be the meaning of this command in SD-WAN world, and how should I put this command into SD-WAN world. It's going to create a lot of headache. So we came up with a tool which can help you to create your configuration from legacy to SD-WAN. As of now, this tool is not open for everybody. It's only open internally, but it's going to come up a launch very soon in a few weeks, which will be available for each of you. You can leverage that tool. All you have to do is yeah.
So if a Cisco router ships without the vManage enabled software on it, would it register to a DNAC controller, and then DNAC would upgrade the iOS, and then it would register to the vBond plug-and-play setup? Like, what's the scenario when it comes from manufacturing? It doesn't have Viptela code on it.
Yes. So there are two things. One is like going forward, we're gonna ship it a Cisco router with Viptela code. But what today we have is like you have to convert your XC/SD-WAN router manually, or there is a bootstrap a step you can follow that, via which you can have your configuration preloaded and do the bootstrap way to upgrade the device. Device will upgrade and go and talk to the PNP. That's one way. But that bootstrap, it technically becomes one touch. It's not true zero touch. So, yeah.
Right. I was just thinking through like workflow on switches that have software and it redirects to a registered DNAC controller, right? Like, would DNAC be able to run that bootstrap script?
Yeah. So the point is like if the router gonna ship with the SD-WAN image, it's gonna happen as you mentioned. But until then, we have to follow a little manual step. So because you have to point out some way to the PNP server. So today you have to upgrade the device and do that. So the best way I would say, let's say you have a device, your templates has been configured, right? And the template is attached. So what you do is just upgrade the device, connect your DHCP port, and let device talk to your controller. So the moment you upgrade the code from XC to SD-WAN, it will go and talk to the PNP and figure out. So that's going to happen. It's just one step, which is upgrade. Apart from that, is everything plug and play. Thanks for the question. So about this tool, what you have to do is today, take out the configuration from your XC device, have the configuration to this tool. It will convert the configuration in SD-WAN way, and it will tell you what command, what models is not supported, and it will list out in the red color and tell you to remove that part. Once you remove that part and there are no exception, it will go ahead and create a template to you. That template will pushed out to your vManage, and you can attach that template to a device you want to. So ultimately, we are taking out all those manual work, you had to do, and we convert in quite automatic way. Just go ahead and paste it and get the configuration, what vManage does it, what it doesn't do, and we can come up with later on those supported parts, right? But you don't need to worry about it. Just gonna figure out what is LAN, what is the WAN, what is IP, what should be the tunnel, what should be the service. Everything is gonna be figured out by this tool and should be done. It's gonna be launched very soon as the public. So do we have any questions on that? Yeah. The only thing you have to keep in mind, your vManage should be reachable from that tool, because it has to be reachable. You're gonna do a couple of API call to do and implement that particular template to the vManage, right? So the policy framework. So we have to understand the policy framework, which is very important. So far what we have discussed is like, we discussed about what is Cisco SD-WAN, and what sort of configuration, what sort of template we use to bring up those parts and the components, right? Now we are going to talk about the policy. The policy is very important here, the data plane, right? So if you look at the policy framework, what sort of policies we have control policies, we have data policies, we have app route, and you have local policies, right? So the policies which are centralized are getting pushed from the vSmart controller to all the way to the VH device, and the local policies are gonna stay in the box where you're gonna have defined local policies and call into one of your template to have those policies. Centralized policies can be for one site or can be for multiple sites. Localized policy is local to you, and that's going to be applicable to you only. So once we bring up the devices from the PNP and have template configured, the next step is like the device is going to download your policies from the controllers. It could be a data policy, it could be the app route policy. In terms of control policy, it is not going to download, because in control policy we can filter the OMP routes, or we can filter sort of hub and spoke scenario, but not more than that. So because that's mainly a traffic engineering scenario, right? So do we have any questions on that? Good. So the topology thing. So if you are aware about that, when we bring up our devices, it is by default full mesh, which does ECMP, right? So let's say you have quite big networks. So you have to plan those, how to customize, how to divide regional-wise your devices, because all of the devices are not going to support the number of branches you have. It's not going to support our scale that way. So you have to plan the scalability. You have to plan how you're going to post your or keep your branches and hub site, and how you're going to connect your branches with each other. So you have to plan those very vastly and figure out how to build out the tunnel, because it's not like all the devices are supporting 5,000 tunnels, 6,000 tunnels, right? So you have to plan those parts and bring out, let's say, go with the custom control, go with the regional solution if you have number of branches more than expected. So there are a couple of solutions for that. You can go with centralized hub, where centralized hubs should be capable to support more channels, should be scalable, and then at the branch level you can have the devices, let's say it supports like 100 tunnels or 200 tunnels, and use that. So you don't need to use the high capacity devices everywhere just to support the number of tunnels what you need. Since we do full mesh connectivity between all the devices and bring up as a first. And there are a couple of scenarios we can do it. Let's say you can have regional way, as I mentioned, but there are a few needs. Let's say voice traffic. It has to go directly. You don't want to go via a hub, because there are considering a delay, jitter loss. It's not simple. So we can have a regional solution, regional policies, but per VPN. Let's say my data connection and everything, I want to keep it regional. I don't want to have those things talk to each other directly, considering my need and looking at my number of sites. But for voice, I can have full mesh. I can say, okay, voice can directly talk to each other, but not other VPNs. So there are a couple of things we can plan. As I mentioned, the scale is very important. We can't have those high-end routers every place, so we have to plan. So and have those sort of routers which can support tunnels between the region based on the need, and then you can have the hub routers as high capacity to build out the regional connectivity and go ahead from there. So these are the high availability scenario we do have available. If you look at what we have, the service side you can have multiple things. Service side you can run VRRP as a layer 2 if you have layer 2 switch connecting to the LAN. If you have layer 3 options, you can run OSPF, advanced OSPF redistribution sort of thing, and BGP protocol. At the WAN side, we have feature called the TLO extension, where you can extend your link from a router to another and another to the same router. So you can ultimately leverage your two links. If you have you have just one endpoint from the service provider. It's not necessary to have multiple endpoints from this provider because it's not feasible every time. But if in case you have, you can directly connect those links to the router. So ultimately, if you are getting two handoff from a provider, you can communicate a link to each. If you're not getting that, you can have extension, what we have today, extend a link from a router to another and leverage that. So ultimately, that way, you're going to leverage both the router as the box level of redundancy as well as a link level of redundancy, right? Having the feature like TLO extension. So do we have any questions? Because if you look at the TLO extension, it's a very often used solution, and there are multiple use cases we have gone through. So if you have any questions. So the important topic where we are, which we are here, is migration. How we migrate your site from XC to SD-WAN, right? That is what we're going to discuss about. So this is your current setup. So your routers are connecting to the layer 3 switch, MPLS is connected, and you have perimeter firewall, everything is connected, running well. Now, when you plan your migration from XC to SD-WAN, we can't just take out from the day one everything, right? We have to plan, we have to make sure the services should not be interrupted. Services should be running fine, and at the same time, we have to migrate my branch, my data center or my services to SD-WAN as well. So what we do is, like, we start from the data center. We start migrating parallelly and make sure the services should not be interrupted, right? So there are a couple of ways we can do it. What we can do is we can have a device converted from XC to SD-WAN and connect the device via one of the link of internet as well as your link from the C router, which is your MPLS. To make sure your services which are already running should not be impacted, should be the same, but at the same time, you should be able to leverage your SD-WAN case, right? So if you pay attention here, so I'm going to call a couple of terms. One is the transport side, another is service side. When I'm going to say transport side, that's where your WAN link is going to come, right? Your WAN services, your WAN transport is going to terminate as a transport side, and the service side is nothing but LAN. So which means the LAN side, the layer 3 switch or layer 2 switch is going to connect to the LAN side, which I'm going to term as a service side, right? So the transport side, which is the WAN, I'm going to consider the C router, which has MPLS, because I don't want to interrupt my network, which is already running. And then I'm going to have another link to the firewall, which is my internet transport, to make sure I should be able to connect to my controllers if they are hosted in the cloud, right? After which, I'm going to connect one of the legs from the service side. When I say service, again, from the SD-WAN service, which is in the LAN side, to the device, which is my data center core. After having this connectivity, I should be able to go and talk to the controllers via internet, as well as via MPLS if I'm netting somewhere, and if my controllers are hosted in the cloud. If they're hosted in on-prem, I have multiple ways to communicate about, right? So that's how the connectivity is going to be. So as I mentioned, I have my transports are connected through MPLS and internet. When I say MPLS, I'm considering your C router as a P for me. When I say me, it's like a branch as a SD-WAN, which is going to be migrated as of now. After which, if you look at how the prefix is going to come, is like they're going to build out control plane and then data plane on top of that, which is my overlay I'm going to call. So there are a couple of terms like overlay. When I say overlay, it's like what I'm learning from SD-WAN. So if you look at the flow here, so all the prefixes, right, from the SD-WAN side are going to come to all the way to the C router, and they're going to follow the green link to the VH router, to the WAN edge router, and give the prefixes back to the layer 3 switch. All the prefixes which are coming from non-SD-WAN sites, they are coming all the way to C router, they are coming to the layer 3 switch, and then layer 3 switch is passing to the SD-WAN. So it's like the graph start from here, getting SD-WAN prefixes from all the way to MPLS and internet, all the way to the switch, and non-SD-WAN prefixes from the MPLS underlaid directly to the switch. So on this side, data center side, you're going to have both the options, both the routes available. You're going to go to SD-WAN, go via this WAN edge router. You're going to go to the traditional sites, you can directly go to the via C router, right? As well as if there are any sites which are migrated on the at branch level, they're going to come to this data center all the way to WAN edge router. They reach out to the switch, and they're going to get the prefixes where and how to go, and then they follow the C router. Do we have any questions on this? The connection? Yeah.
Do you generally recommend putting the WAN edge devices behind a firewall or directly terminating an internet circuit into the V edge or C edge?
So it's your data center. You're going to have firewall at any case. But we do not, I mean, it's not needed. As long as you're fine, we have.
Well, right. It may be an option. You could run it through the firewall.
Yeah.
And then if you're using that circuit for both, user-bound internet traffic as well as SD-WAN establishment, you can do your kind of shaping from a QoS perspective at one choke point on the firewall.
Yeah.
But you also could put the WAN edge directly connected to the internet circuit and not have a firewall for all
it's not necessary. It's not necessary. Yeah. The reason I said because we're talking about the data center design. Data center design, you're gonna have the firewall. So as you said, it's not necessary. It's not important to have firewall on top of the VH devices. You can directly terminate a link to the VH device. There's no issue. Yeah. We have things to take care of those control plane track and all those things. Yeah. So at branch level, it's going to be simple because the branches have the way are going to get the way from data center to reach out to non-SD-WAN branches. So there are a couple of things we can point it out when we leak the routes from SD-WAN to non-SD-WAN or non-SD-WAN to SD-WAN. Let's say you have this small branches. You can have one data center or one regional site where we can leak those routes. Or if you are a large enterprise, you can have multiple ways. You can have transition hub where you can leak the routes of SD-WAN to non-SD-WAN, and then have the branches going through that, or regional branches going through that based on your route filtering, what you're going to apply on those routers. And that is how we can achieve that part. And that way, you don't need to do underlay overlay route leaking. When I say underlay overlay route leaking is SD-WAN and non-SD-WAN. So you don't need to do it at a branch level or every branch level. All you can do is go at data center, or if it is a large enterprise or something you are in across the globe, you can have your regional exit. Let's say APJC should exit from APJC hub for non-SD-WAN prefixes, and EMEA should exit from EMEA hub for non-SD-WAN prefixes, and US should exit from US hub for non-SD-WAN prefixes. Similarly for SD-WAN. So if you look at the branch migration, you can take the router which is already running IOSXE XE code. You can just have the SD-WAN code install and replace and convert that router to the SD-WAN. So I'm sure all of you are aware about how we did convert and how we are converting the XE router to SD-WAN. It is a very simple process. Have your SD-WAN image on the router and make sure you check the memory requirement and then convert that that image, that particular router, which means just a simple upgrade from XE to SD-WAN, and the router will be SD-WAN. And then, as we discussed, once we have your ports connected and DHCP is going to do plug and play PNP and get it connected to the plug and play server and get the configuration pushed out from it. All right. So that's how it's going to be. Do we have any questions on, especially when how we convert on XE to SD-WAN? No. So the point is here, if you look at the differentiator pointer from the data center to the branch is this one. At the data center level, you're going to have underlay overlay route reachability via SD-WAN and via non-SD-WAN. But if you look at here, the branch level, because your data center is already built out on SD-WAN. Now, from the branch, you're going to build out your tunnels from the via MPLS transport or internet transport, and you're going to have both the routes available, because you can get those SD-WAN routes directly to the other branches which are running on SD-WAN and the data center, as well as non-SD-WAN prefixes from the data center. So the branch migration is very easy. You don't need to have underlay overlay route leaking every places or every branches, but you can have at hub level or one of the regional data center. So similarly, if you have two XC1 SD-WAN routers running at the branch level, you can convert them together. There is no need of going one by one and have them running on SD-WAN, and then plug and play and leverage both the transport and run the protocol like VRRP or OSPF. You're free to run. If you have layer 2 switch at the branch level, you can run VRRP and use TLO extension to have both the links uses. And if you're running OSPF or BGP, you can run active, and ultimately leverage both the routers and both the links. All right. So if you look at the flow level, all the local prefixes will be injected to the OMP via redistribution, as well as all the OMP. When I say OMP, is like protocol what we are running from the controller to the VH device to learn the route of a site to another. So that is how we're gonna get it. Like we inject local routes to the OMP and learn the OMP route, which means SD-WAN site routes and non-SD-WAN site routes from the data center to the branch via OMP. So there are scenarios when you have MSP managing the router itself, right? So in that case also, there is the option you can leverage SD-WAN. You can have the router connected behind the MSP managed router, which is C router, and take one of the legs and connect to that, as well as you can have a leg from internet and connect that to the SD-WAN router, and have your code upgraded if it is XC ISR, and keep the running your BFD sessions. Build out the tunnels to the SD-WAN site and learn the prefixes. As well as you look at the workflow level, it's going to be the same. You're going to put your local prefixes to the OMP via redistribution, and then OMP prefixes are going to come to you via OMP redistribution to the local protocol. That's how you're going to have the communication from a branch to the data center or to another site which are on SD-WAN. Right. Do we have any questions, especially on the MSP level of migration when we have MSP managed router at branch? How we gonna have SD-WAN running there? Right. So this is how the flow is gonna look like. Yeah. So this use case is quite common as of today. So let's say you have a router running as a WAS, right? And at the same time, you would like to leverage SD-WAN. Now, if you look at, we are coming up with the same box solution where you're going to have WAS and everything running in the same box, like feature like call that app QoE. But as of today, it's going to be two box solution, right? So let's say left side router is my router, which is WAS, and the right side router is my SD-WAN router, right? What we did is we have got it 2 VRF on the router, which is running left side, which is a WAS. Technically, we put the transport side in a different VRF, let's say VRF1, and service side and VRF-B. That way, I separated my routing table of transport side and service side at the router level. And then VRF-A is connected to the VPN 0, which is transport VPN of the SD-WAN router, and my internet is also connected to the transport VPN of SD-WAN router. At the LAN side, I have layer 2 switch because I don't have layer 3 switch at the branch level. I'm running VRRP. With the help of VRRP, I made my left side router, which is WAS supported router, as an active router. So there is a way. The first step is like I can make him active. I can send him the traffic and ask him, through the traffic chaining, send the traffic to VRF-B and then send it back. If I do that, the same packet is going to be processed twice on the same router, because I'm going to send him, you're going to send him back, and again, you're going to come back and take the SD-WAN. But with this solution, what I'm talking about here is like I'm going to make this router, which is a right side, which is a router supported SRST or WAS as an active router. I'm going to send all my traffic to him, and that traffic going to land to the VRFB. It's going to leverage the SRST or WAS, and then the traffic is going to come back on the router, which is on SD-WAN, and from that will be tunneled through the MPLS or through the internet. Now the problem could have when the return traffic comes in. So that is where we have to be very careful. We have to plan or define a policy to make sure something coming back should hit the router connecting VRFB. Should not come back here. It can cause asymmetric routing, right? So to avoid that, we have to have a data policy. Say, you know what, if this is my source, this is my destination, please hit the VRFB interface at the SD-WAN router to make sure it is simple, it is symmetric, right? Which means traffic gonna follow is active, it's gonna exit via VRFB and go to the SD-WAN side and come back the same way, and things running as usual. There is another use case. So what we did just now was just a layer 2 switch you have had in the branch. Now we are going to have a layer 3 switch at the branch level. So this is just workflow what I just discussed. Now some reason I have layer 3 switch at the branch level. What I can do is I can run a protocol like OSPF or BGP. I can filter that a similar way, or I can do just ECMP, should be good. I can just have my ECMP running, or I can prefer the path, one of the path. If you look at the plus is like preferred path, so I can prefer this path as a primary and go back, and again with the data policy, I can come back the same way, or with the routing protocol, I can say BRFB, I'm the best one. I can come back in the same way. And if the router B goes down or this link goes down, everything will come directly to the SD-WAN device. If router B itself is out, I mean the VRFB router itself is out, everything will go via internet, right? So it's always going to be a backup path when router when the WAS or SRST router goes down. Do we have any questions on this? All right. So if you look at what we discussed some time back, when we discussed that you have had services like WAS or SRST. At that moment, we had a VRF in the router, which is at the right side, which is SRST or WAS router, right? Now, there's a scenario I don't have VRF, which means everything, the routing table is going to be the same. If I send it, if I receive it, everything is going to be the same. What we have to do is, so we have to play with the protocol like BGP and filter those routes. Let's say I'm going to say, anything I'm getting from the MPLS, it's not going to send on the LAN interface. It's going to send on this interface. I'm going to block that part. Anything coming from the service side, I'm not going to prefer or send it to my WAN interface. I'll send it to him. It's like we have to play a lot of route filtering preferences to make sure anything goes from the LAN side should always go to the router and should take that as a SD-WAN route as a next hop, and it should go to SD-WAN. Anything comes back from SD-WAN, if let's say if it is following MPLS tunnel, should come back to that router, and then that router should point to the SD-WAN, and then SD-WAN should point to the router back for the same, to follow symmetric path, to follow the DPI thing, and come back to the end. So that is what is the key differences, what we discuss with VRF and without VRF. Without VRF, we're going to play with the routing protocol to tune the things to make sure it should not create loop, it should not have mix and match with the routing. With VRF, it was quite simple. Same use case. Now, in this case, we are going to have a BGP running at the LAN side. In my previous use case, we had no VRF, but we were running VRRP. But in this case, I have VRF, but I'm running a routing protocol like BGP, where again, I'm going to play with the filtering at the right side router, which is WAS router, as well as I have to filter the things here and prefer one of the path to make sure I should hit my services as a primary to the router, which is WAS router or SRST. And that is how we can follow that.
Hey, we have a couple questions on WebEx.
Sure.
And it's related to the previous slide.
This one?
Yeah, I'm trying to read it here. There it is. Is it all IBGP in the branch in this scenario? Or is I assume it would
We can run both. We can run IBGP, we can run EBGP is fine. In my case, I just followed EBGP.
Okay.
Yep.
And the other one is, I understand how the VRRP controls the outbound, but how do you control the inbound to make sure it's symmetric?
Yeah, so for that, we're going to have a data policy to make sure anything coming as a destination to my layer 3 switch should hit the SRSC router as a next hop, which means in my policy, this is going to be next hop. And there are a couple of ways. One is a policy, we can have centralized policy. Another is I can have a local ACL, I can say next hop is this. Anything coming, match this, the next hop is this. So there are a couple of combinations which we can use to set a path to make sure it should be symmetric. Yeah. Do we have any other question about a feature about, let's say what we discussed, a couple of scenarios. You think that we have those challenges or we have faced in the field and you would like me to address that, especially on the design part, especially on the product part, just let me know and we can discuss right now. Because we have covered a couple of scenarios. If you look at the WAS, which is very common use case we get in the field these days. And the migration scenario like PNP, my friend asked the question like how we going to leverage PNP when we have router running on SD-WAN. So if you have any questions on those, we can go one by one and take it right away. Any use cases you have? Yes, sure, go ahead.
One thing we run into a lot is customers will have services in the underlay. So okay. In VPN 0, they might have a SIP service hosted by their MPLS provider.
Right.
And the correct response for services in the underlay is to go through some sort of regional hub and get into the underlay that way. But that's unacceptable from a latency standpoint, and that they won't have a layer 3 core. So I've seen how you can kind of extend VPN 0 through a vEdge into the core, but if they don't have a layer 3 core, that's not really an option. I've heard you can terminate VPN 0 onto a loopback, but I haven't seen how that's done. So what do you generally do in that scenario where they need SD-WAN site to non-SD-WAN site or SD-WAN site to services in the underlay, and they won't go through a regional hub? How do you generally design that?
So at the branch level, right? Yeah, so there are multiple ways. If you take a use case of SD-WAN, XC-SD-WAN, and vEdge, we have two different scenarios altogether. So we are working on a couple of scenarios in SD-WAN to come up and to make sure this migration, especially this use case, should be very simple and I should not use any other or extra device in order to achieve that part. We are working on that part. What we have done so far was we used to have, as you said, connect the provider edge router to the VPN 0. From the VPN 0, we can have normal interface without tunnel. We have a loopback interface which binds that tunnel interface, and we put that link from the VPN 0 to the service side and have the branch directly talk to the underlay. But when you do that, you have to place filtering at branch level, which means we are going to filter every branch about each route, right? Because we just need voice services to talk to each other, but we have to filter other services because other services could be available from other branches as well. Because I'm a branch, I have 10 branches. All the branches are going to leverage the same service, right? So, which means all the branches are going to directly leak to the MPLS, which means my routes are available from MPLS as well as SD-WAN. So we have to filter those parts, make sure I should only talk to my, or I can have the policy. I can say if you want to have destination as SRST, hit this as a next hop. If you want to have a destination as something else, this is what you do. So a couple of scenario what I did, as you pointed out was I use sub interface. I use the sub interface and connected the interface to the MPLS router. I created two sub interface tunnel. One tunnel was in transport, and another sub interface I use in service side. I kept in the same VPN. So what I got is one sub. So technically, I'm using same one physical interface. That physical interface I convert into two sub interface, like VLAN model. One sub interface is my, let's say, .1 VLAN, let's say VLAN 2, which has IP address .2. Let's say 192.168.1.2. Is connected as a transport. I enable tunnel interface and kept in VPN 0 and connected to my MPLS router. Another sub interface I kept in VPN service VPN, which is my VPN 1. Even today also in ISR we can do, and XC-SD-WAN we can do it. And then I got VLAN 3 here at service side, and I got the IP address, let's say 10.10.3 here, right? ultimately it is one physical interface, but I have two sub-interfaces. Now routing table is the same. We have used just one interface, but we got two sub-interfaces in that, and we are going to reach to the MPLS provider directly from the service side as well as from the transport side.
And does that, I was having a little bit of trouble following you, but does that require two IPs on the MPLS circuit then?
Yes.
Okay.
In that case, yeah.
Okay. Have you guys thought about just allowing leaking between VPN 0 and the services VPN to just do straight route leaking?
We don't have plan at the moment doing that, because
that seems like the simplest.
Yeah, it's like I'm giving a loaded gun to you, so that's quite difficult. And
well, like you said, that requires a bunch of special filtering as well.
Exactly. So like let's say we do that, which means each and every branches are advertising same route through the underlay, through the overlay, through the SD-WAN, through the MPLS, right? And like the traffic is quite confused. Should I take this path or another path? And you can't apply filtering each and every level of each and every hop, right? So you have to be very careful when we do that part. So we are in work. We have discussed with a couple of customers and a couple of key customers we are discussing. So we explain the process. You know what? We can do that. People does that. But think about the scale what we do. We can go. We have customers running more than 10,000 branches at this moment, and I'm working a couple more. So where if I go with this scenario, how can they gonna filter? That's not simple way to filter, and that's quite painful. But there are a couple of use cases which can help in this case, and I agree on that. But we have to just make sure we should filter those very sensitive way. Make sure if I'm learning from SD-WAN, I have to prefer SD-WAN as the primary. If I'm not learning something from SD-WAN, I can go with underlay. But there are ways like sub-interface way or tomorrow once we have in SD-WAN, we have loopback available in transport side. You can have this one interface running, and you can leak from the VPN 0 connector cable to layer 3 switch. That's one way. So these are the way we can do as of today. And if you have VH device, you have loopback directly. You can do that. Again, the filtering is where we have to play everywhere. Yeah. So any other questions on these parts? Because these are very important topics when we get the questions like when we have WAS or when we have services like SRST, and you have to have connectivity directly to that service instead of going to the hub or one of the exit point. All right. So as in summary, so what we discussed, like you have to plan your network properly, and have your and as a preferred model, we always appreciate and recommend you to have cloud controllers wherein you are not going to have those security management parts and having using instances, sizing and scalability and planning things. Those all are taken care by Cisco as a service to the customer. And the sequences in migration, as we pointed out, like migration is very, very key topic and very important steps we have to follow. We just can't go ahead with every site route leaking or a couple of site route leaking. So we have to plan regional way from the route leaking from underlay and overlay. When I say underlay, overlay is like SD-WAN and non-SD-WAN. We have to plan that part in a sequence manner and make sure we should do a proper filtering when we are doing that part. And as simple as our routing is gonna be, it's gonna be good for the migration, running a routing protocol like OSPF and BGP. When you don't have much filtering, it's going to be straightforward because we use the concept of the VRF where you're gonna have underlay and overlay routes separated, and you can have the two different control plane and data plane parts, right? Yeah. So I think that is all for now.